Welcome to this tutorial for bone segmentation with 3D slicer in the version 5.0.3 using pelvic bones as an example. Here you can see the start screen of 3D slicer, which opens directly after starting the software. At the beginning, I want to show you some very basic functions of 3D slicer, like the import of DICOM data or some basic tools. So let's start with the import of a DICOM dataset. To do so, we have to activate the module add DICOM data, and then we can import the files. After we navigated to the right directory, we can choose the folder that contains our DICOM data and click on import. Today I use the data of an anonymized CT scan as an example. As you can see, the software loads the data into the database. All data which are imported into the 3D slicer DICOM database are copied into a folder by default on partition C of your hard disk. In the DICOM database view, we can see three tables. The first one shows the patients, the second one shows the studies, and the third one shows the series. Today we want to load one series into the editing mode. In this case, this is an abdominal CT scan with a slice thickness of 1.5 millimeter and a soft tissue kernel. You can also load several series at the same time. To do so, you have to mark all of them and click on load. You want to load only one series, a double click on the series you chose does its job as well. As you can see, the data are displayed in the standard view of 3D slicer. In the top right corner you can see the 3D view, and in the other windows you can see the three different planes. If you want to change this view, you can click on that button and have several options to choose. For example, it's possible to display only one of the planes. Like I show you now, we will only display the transversal plane and now change back to the standard view of 3D slicer. Here we can see the three reconstruction planes from the CT scan and the 3D view. It's also possible to show all of the planes in the 3D view by moving the mouse button to this little staple pin in the left top corner and then activating this eye symbol. When we check the three-dimensional view, we can see our transversal plane there now and activate also all of the other reconstruction planes to get a first impression of the three-dimensional appearance of our anatomy. It's possible to scroll through the planes and move all of them together in the 3D view to get a view from all perspectives. It's also possible to deactivate their three-dimensional visualization again and return to the standard two-dimensional view. Now I want to show you two different options to change the window settings. The first option allows you to change contrast and brightness by moving the mouse with a pressed button. And the second one allows you to create a little box which uses the software to adapt the window setting automatically to the area which is inside the box. To zoom in and out within a plane is very easy as well. You just have to push the right button of the mouse and move it up or down. Another very helpful function in some cases is that the other planes adapt automatically when you move the mouse with a pressed shift button. This can really help in some cases to identify some critical anatomical structures. So let's start with the segmentation workflow. The first step of this is that we have to start with an initial manual segmentation, which can be used as a starting point for a semi-automatic segmentation tool called Grow from Seeds later. To start with the segmentation process, we have to open the module Segment Editor. On the left side, you can see all the tools which are available within the segment editor. To be able to use them, you have to create at least one segment first, but now we have created already two because we need one for our structure of interest. In this case, these are the bones, and the second one for the background. The first tool which I use to start a segmentation is the threshold tool. This gives us two options. On the one hand, it's possible to perform a simple threshold-based segmentation, and on the other hand, it's possible to use it to create a Hounsfield unit-based mask for our painting tool. You have two options to change the upper and lower limit of the mask or the threshold-based segmentation. You can either type in a given value of Hounsfield unit or you can change the slider. For this segmentation, I will use a value of 210 as the lower limit of our mask for the painting tool. I always check parts of the bone at which the cortical does not have a good contrast to the soft tissue to make sure that most parts of the bony surface are included into the mask, and at the same time I try to reduce the included background noise as much as possible because this will make the following segmentation process much easier. When we are satisfied with our mask settings, we can click on Use for Masking. Next step is that I activate our bone segment, and now it won't be possible to paint outside of our defined mask, which is very helpful when you want to define the boundaries between bone and soft tissue precisely. Now I can start marking in every reconstruction planes parts of our anatomy which we want to include in our segmentation. As you can see, I don't have to work very precise when using the painting tool because the defined mask does not allow us to paint on areas which are not included into the defined Hounsfield unit range. Only in regions which contains bones which should become part of the segmentation and bones which should not become part of the segmentation, you have to be a little bit careful. Like at this place where I want to make a distinction between the acetabulum and the femoral head. Especially at this part of the pelvis, I can recommend to work very precisely, at least at one slice within every reconstruction plane, because this will make the semi-automatic segmentation much better. In general, I recommend to mark around 5 slices within every reconstruction plane distributed evenly over the whole ROI. In some anatomical regions, the orientation might be sometimes a little bit difficult. In those cases, it can help to change to a different reconstruction plane because every slice you mark there will also be displayed in the other reconstruction planes. So in this case, it is much easier for me to make the distinction between the fourth and fifth lumbar vertebrae in the sagittal plane. Then I return now to the transversal plane and scroll through the slices. You can see that the plane I marked before in the sagittal plane is now visible here in the transversal plane as well. And now I can continue easily with the details of fourth and fifth lumbar vertebrae. To complete the transversal plane, only one last step is needed. We have to mark the background in some slices. To do so, we have to first deactivate the checkbox of editable intensity range, because now we don't want to draw within our mask. We want to be able to also draw outside, because now it's our task to just roughly mark the background in some slices. You don't need to pay attention to the details in most areas, only in those where bounds which should and which should not become part of the segmentation are close to each other. One further tip is to mark the foramina of the sacrum with the background segment. By doing so, the preview of the Grow from Seeds tool will become a little bit more precise. This tip is based on my experience with segmentation using 3D Slicer. Once you have become familiar with the software, you will gain your own experiences and you will quickly learn at which parts of the anatomy it's helpful to work very precisely and at which parts you don't need to do that. Okay, now we are finished with the transversal plane and we continue with the coronal plane. We repeat the same steps as we did before, at first with the coronal plane and afterwards with the sagittal plane. Make sure to activate the editable intensity range checkbox again when you change back to the bound segment, because now you want to use your mask again. As you can see, we repeat the same steps as we did before, and at least in one slice we work very precisely at the hip joint to separate the femoral head from the pelvic bones. Okay, now we are done with the coronal plane and continue with the sagittal plane as explained before. Now we are done with the initial manual segmentation and I recommend to save the results we have achieved so far. When you click on Save, 3D Slicer will open the Save Scene and Unsaved Data dialog, and it offers to save 3 files. The first one contains the information about the last view within 3D Slicer. The second one contains the imaging data, and the third one contains the results of our initial manual segmentation. It's also possible to change the names of the files and the directory where you want to save them. The last thing you have to do is to click on Save. Now we will use the Grow from Seeds tool to fill the slices between those which we have marked during our initial manual segmentation. To do so, we open the Grow from Seeds tool and click on Initialize to start the initialization process of the Grow from Seeds preview. Now the software will need some time to calculate the results. Don't be afraid in case 3D Slicer freezes and wait for some minutes. It's just the time 3D Slicer needs for the calculation. As you can see, it's done now, and the preview is indicated by the green and yellow color for the two segments with a little bit less opacity than the initial segmentation. When we scroll through the slices, we can see that 3D Slicer filled most areas between the slices which we marked in our initial manual segmentation. But there are still some areas which need further optimization. To achieve that, we just have to add some additional seeds in areas we want to improve. To do so, you can use the paint tool. But before we do that, I recommend to deactivate the checkbox at auto update, because otherwise the software would need some calculation time every time when you added one additional seed with the painting tool. Okay, now we search for parts of our segmentation we are not satisfied with and correct them by adding additional seeds using the paint tool. I will show you some of them, like at this part of the femoral head, which contains some yellow voxels, although we do not want it to be part of the segmentation, so we use our green background segment to erase them. Now one further example. In this place you can see that there are green areas within the sacrum, and of course we want the sacrum to be a part of our bone segmentation, so we correct those areas using the yellow bone segment. I recommend to add in around 5 slices per reconstruction plane those additional seeds, and afterwards you can update the preview for the first time. When you scroll through the slices now, you will realize that the preview has already become much better, but in most cases you will need some further iterations of improvement. When we are done with the improvements of our preview in the two-dimensional view, we can also check the preview in the three-dimensional visualization, like you can see here. Now I also add the initial manual segmentation to the three-dimensional view, just to give you an impression of how the preview and the seeds look when they are together within one three-dimensional view. As you can see, we roughly marked the green background, and within the pelvis there are only some slices which are marked with the painting tool, and all of the other areas are added by the grow from seeds algorithm. At the end of this part of the segmentation workflow, I recommend to save again, because this is the last part at which the grow from seeds preview is accessible. Once you applied your preview, you can't change the applied segmentation back to the preview mode. After we saved our preview, it's time to apply it, to create a segmentation based on our preview. Our preview is applied now, and now we need just some further optimizations, like smoothing or the removal of some remaining artifacts. At first I want to show you the scissor tool. To use that, you have to choose the segment you want to edit, and then you can activate the tool. You have different options to use. Now I demonstrate erase inside. You can use this tool in the two-dimensional view as well as in the three-dimensional view, as I showed you. The next tool I want to show you is the remove island tool. You can use that to easily remove some artifacts which do not have a connection to the main part of your segmentation. As before, you have to choose the segment which you want to edit, and then you can click on apply, and all parts which are not connected to the biggest part of your segmentation will be removed. The last tool which I want to show you is the smoothing tool. You can use that to improve the surface of your segmentation. I had good experiences with the median smoothing method with a kernel size of 3 millimeters. And now the software will need some time for the calculation again. Of course, you have to check your segmentation result against the DICOM data to make sure that no errors occurred, like at this place where a little hole in the iliac bone was created. Those small defects are easy to correct, but at the same time it becomes obvious now why you should try to achieve a growth from seeds preview which is as good as possible, because now when you are working with an applied segmentation you have to make the correction manually in every slice. Exporting our segmentation as a STL file will be the last part of our 3D slicer bone segmentation tutorial. To do that, we have to open the module Segmentations. There we activate only the segment which we want to import into a file. Then we can choose Export to Files and Visible Segments Only. There we can change the directory. When we click on Export, our segmentation will be done and 3D Slicer opens automatically the folder where we saved our STL file. As you can see, I can open that now using Mesh Mixer, and now our segmentation became a printable STL file. I hope this tutorial helped you to learn bone segmentation with 3D Slicer, and thank you for your attention.